Hello, we're Group 10, and I'm going to talk to you about our distributed systems project, which is a real-time online bidding platform. What is bidding? Bidding is an offering of a setting price one is willing to pay for something or demand that something to be done. Why bid? The most important reason is that you may pay how much you want to pay for an item if you're a buyer, and a seller may receive more for an item that they place up for bid than they would have expected. There are also the benefits of transparency, being able to see what other bidders are bidding, and rarity, being able to get items that you may not be able to get otherwise. So currently there are other bidding platforms, but we view them as somewhat boring and tedious, and we want to make this idea of bidding more exciting. So how can we make bidding more interesting? In our platform, we include the idea of limited bidding slots. So there are a set number of seats available for bidding on an item. The idea of playing dirty while you bid, that bidders have tools that they can use to take advantage of when bidding to outbid other bidders, and the use of a robot that enables you to automate your bidding. So if someone else outbids you for an item, then the robot will take care of producing a higher bid for you. Some of our basic rules. From a seller's point of view, anyone on the platform can put an item up for bid, setting a base price, providing a picture of the item as well as a description, and the number of limited seats that they would like to allow. The items can be taken off of the bidding platform, but not after bidding has already begun. From a bidder's point of view, the bidder is able to bid on items that are listed on the platform. If no one bids on a certain item within a certain time limit, then that item will be taken off the platform. Once bidding is complete, the winner and the seller of the item will have a contract generated for them and set to each of these participants to notify them of this exchange. As far as the architecture, each of the users of the application will run this application on their computer systems. Multiple users will be able to connect to one another, and users will be able to be dynamically added and removed from the system. There will be a configuration file that contains information of all the connected users so that they may communicate with one another. The application will operate on a per session basis, meaning that on each run of the application, once all users are disconnected, all the information from that run will be lost. And this is just a brief mock-up of what our architecture would look like with multiple users connected to one another. As far as our design, we have game elements incorporated into our bidding platform so that users can accrue points to buy different tools for bidding. They can buy free money, which they can use for bidding purposes, or blocking, which prevents other users from bidding on items that they want. As was mentioned before, there's the idea of bidding slots, which users have to compete over in order to bid on an item. So our user interface will consist of biddable items that users can review and find out the details of. They will allow users to post items themselves, as well as view their current items, which would consist of items that they are selling and items that they bid on. And here is another mock-up. This is for our interface, which just contains the main interface, which will have a list of the items, as was just explained, also with the options of buying and selling. And on the right, there's the item information, which details all the information provided for a particular item and allows the user to bid. Challenges. So for this project, we will be using the Go programming language, which none of our group members are familiar with, so this will be a learning curve that we will have to overcome. As with all distributed system projects, concurrency is a challenge for us. We will have to make sure that all data between users is concurrent for all the bidding actions. Since we won't be using a database, data storage will also be an issue in memory, dealing with the memory component of each of the different applications that the users are running. There's also the challenge of adding nodes dynamically through the use of the configuration file. And we also have the added challenge of partitioning users into specific groups so that only those interested in a particular item or bidding on a particular item will be a part of the groups and receive messages pertaining to that item. There's the issue of scalability for our platform, which consists of adding users and adding more items and more information and having that be a scalable process. There's also the issue of authentication, which makes sure that users who are allowed in the system are the only users that are allowed.